Okay, so we're going to start with chapter 15, which is the prerequisite chapter. So it should be some fairly simple things for the most part. Definitely review, probably even all the way back to maybe middle school, so it's going to take a minute for us to remember some things. So to start with, we just want to remember order of operations. So this is just a little graphic to help you remember. Remember that when you multiply and divide, that's left to right, and add and subtract is left to right. So it's not that you have to multiply before you divide. It's just that you have to do the multiplication division before you can add or subtract. Okay, so some examples. If we evaluate, first of all, just means you're going to figure out what it is if you plug in a value. So evaluate usually means they're going to tell you what a variable is worth. So it's a good idea when you plug in values that you put them in parentheses, if they're negative especially. So our numerator is 3 times negative 4 plus 2, and our denominator is negative 4 minus 1. All right, so that gives us negative 12 plus 2 over negative 5. So negative 10, because negative 12 plus 2 is negative 10, over negative 5, which is just 2. When you're working problems for me, I need you to show work. I don't need you to show every single step. Like if you can jump from here to here, I'm okay with that. All right, so next we're just simplifying, which means all of the numbers are there. We don't have to put any values in for variables. So now it's just a matter of can we work piece by piece. So first of all, on this numerator, we need to figure out what's going on in those parentheses. So I'm going to do that all at one time. So inside those parentheses, you have 2 squared, which is 4, plus 3 gives me 7. So again, 2 squared is 4, plus 3 gives me the 7. On the denominator, the first thing that needs to be done down here. So again, you have a numerator, you got to get that down to one number, and a denominator, you got to get down to one number. So I did the first step on the numerator. I figured out what this guy was. On the denominator, the first thing you're going to do is this division. So it'll be 12 plus 8 divided by 4 is 2 minus 2. All right, so back to the numerator. So I'm going to try to simplify as I go, but on the top and the bottom, just make what I'm writing down less. All right, so if you look here, you have subtraction, division, and this is just multiplication because these parentheses aren't really serving a purpose anymore because that's just a 7. So I could just as easily put a multiplication sign here. All right, so left to right, we have to divide and then multiply. So we're going to do 15. And then we'll have minus 3 because 9 divided by 3 is 3. And then times 7. On the denominator, we can do 12 plus 2 is 14 and then have the minus 2 still. All right, so next on the numerator, we have to multiply before we can subtract. So it'll be 15 minus 21 because 3 times 7 is 21. And our denominator, we're now down to 12. All right, so now back to the numerator. 15 minus 21 is going to be negative 6. Divide that by 12, and we have negative 1/2 as our simplified fraction. All right, number 3. We're going to simplify. This time we have variables, but we aren't told what they're worth. So all we can do is simplify to a simpler expression. We won't get a single number as our answer. All right, so again, I'm going to keep everything that's outside and see what I can do with what's inside these brackets. So first of all, inside these parentheses, can I do anything with x squared minus 2? No, because they're not like terms. So we're going to distribute that 6. So it'll be 6x squared minus 12, and then a plus 5. All right, so again, keeping this 18 squared plus 4, 18x squared plus 4. These brackets are really just parentheses now. The only reason there are brackets here is because there are parentheses inside them. So in here, we're just going to combine all of terms. So we can put these guys together. Negative 12 plus 5 is negative 7. So we have minus. I'll make these parentheses and call it 6x squared minus 7. Alright, so now we have this negative that we need to distribute. So this would be negative 6x squared plus 7. And again, bringing down that 18x squared plus 4. Alright, now it's a matter of combining some like terms again. So 18 minus 6 gives me 12x squared. And 4 plus 7 gives me, what is that, 12? No, 11. 11, sorry. Alright, so that's your brief recap of order of operations and doing that with variable expressions and doing it where you evaluate expressions. But it all goes down to, can you do the order of operations? Alright, so the next thing, which you've seen, but you may not have seen all of the pieces, is can we talk about different sets of numbers? So first of all, a set is a collection of elements separated by commas and enclosed in braces. So these fancy little bracket things are your clue that you have a set of things. We tend to deal with sets of numbers, but it could be sets of letters, sets of pictures, sets of whatever. Alright, the empty set is when there's nothing in your set, and we use this symbol that means there's no solution or nothing to represent that. Alright, so some terms that may be new to you as far as math is concerned is an intersection and a union. For an intersection, it's just like an intersection in the highway, it's where they cross. So if I have two sets of numbers, an intersection, which is going to have this symbol right here, this means an intersection. It means where they overlap. Which ones do they have in common? Okay, so it's elements that appear in both sets. Alright, for a union, it's like when you unite people in marriage. You're taking two families and creating one family. So everybody from both goes into one big new group. So if we have this symbol, that's the symbol for union. It looks like a U. Union starts with a U. That's how you can keep them straight. And it's going to be all elements found in either set. So not where they overlap, but everybody from everybody. Alright, so I think it's the next slide. Yeah, there's nothing else on this one. Alright, so examples of that. They give you two sets. And you notice that this problem and this problem give you the same two sets. So you have this set and this set. Here they want the intersection. Here they want the union. Alright, so intersection. What do they have in common? Where do they cross? So, again, fancy brackets, and I'm not always awesome about making them either. Just do the best you can. What do we see in both of these sets? I see a 4 in both and a 6 in both. And I believe that's it. So 4, comma 6, another fancy bracket, and you're done. Alright, union is everything. And you just don't have to repeat yourself. So, from the first set, there is a 2. Sorry. And then we pick up the 3, and then the 4, and then the 5, and then the 6, and then the 7, and then the 8, and then the 10. So it's all of the numbers that were in both sets. Alright, so again, maybe a little new, but definitely not difficult. Okay, so the next thing that's in this section is the real number system, which again, not new, but it's probably been a while since you specifically thought about what kind of number is this. So remember that our real number system, and it's called the real number system because we do have something called imaginary numbers, and we'll get to those down the road. So for real numbers, that's any number that's not imaginary, anything that does not involve the square root of a -1. Okay, so those real numbers are split into two categories. Rational numbers, I can write it as a fraction, or irrational numbers, I cannot write it as a fraction. So examples of irrational numbers are pi, or e, which you may or may not remember learning, or any kind of decimal that goes on without repeating itself and having no set pattern, something that just goes on forever and ever and ever. Anytime you take the square root of something that is not perfect, it's going to be irrational. So if it's not the square root of 9, which is 3, or the square root of 81, which is 9. If it's anything other than those perfect squares, when you take the square root, you get an irrational number. So rational is anything that can be written as a fraction. So like 1/2, or just the number 2, or 2.5. All of those are things that I can write as a fraction, or the square root of 9, because that's really just the 3. All right, so those are some examples of rational. Irrational numbers we don't break down into smaller categories. It's irrational, that's it. For rational, though, those get broken down into smaller categories. And as you go down, this gets smaller and smaller. So rational is all things that can be written as a fraction. Positives and negatives. We'll make a couple of those negatives. Integers are the positives and negatives, but without fractions. Okay, so this is no fractions. Unless they're mean and give you something like 10 over 5, which is really 2. So keep that in mind. All right, whole numbers are when we knock the negatives out. All right, and then natural numbers is when we knock the 0 off. All right, so rational is anything that can be written as a fraction. Integer is positive and negative counting numbers, so no fractions. Whole numbers is 0, 1, 2, 3, 4, yada, yada, yada. And natural is 1, 2, 3, 4, blah, blah, blah. All right, so what are you going to be asked to do? You're going to be asked to identify numbers. So I give you a set of numbers, and I want you to tell me which numbers are in which category. I think in your book, your questions on your assignment are going to be worded slightly different, but it's the same concept. So you're just going to, like, maybe it'll give you a number, and you have to say all of the categories that it fits into. Okay? All right, so for this problem, we want which numbers up here are natural numbers. So which numbers out of this set fit the category of I'm a 1, 2, 3, 4, 5, 6, 7, 8. All right, so this is a no because it can't be negative. Natural doesn't include 0. Natural does not include a fraction or a decimal or a weird symbol. Remember, the square root of 8 is not perfect, so it's going to be irrational. It's yucky. The square root of 16, though, remember, is really just 4. So natural numbers, the square root of 16 fits the bill because it's really just 4. All right, whole numbers, we pick up 0, and that's square root of 16 because it's just 4. All right, integers, we want positive and negatives, but we're still not looking for decimals and fractions. So we pick up the -3. All right, for rational, we're going to pick up things that are decimals and fractions, but like pretty decimals, so we can turn into a fraction. So we still have the -3, the 0. We now are going to include 1/2 and 0.95 because those are fraction and pretty decimal. For irrational, we are no longer talking about all of these other numbers that we've been talking about. Those were all rational numbers. So irrational is going to be the crazy guys, so pi and the square root of 8. And then real is all of them. Everything we're going to talk about at this point is going to be a real number. All right. All right, so absolute value. Again, a concept that you've seen before. You may have never seen the fancy definition of absolute value, and that's all that is up there in that first blue box. Absolute value is distance from 0. Okay? And it can be defined as a piecewise function where we're x if it's positive and we're the opposite of x if it's negative, which is the positive version. So how far is it from 0? What we're going to do with this is not as straightforward as tell me the absolute value of -3. It's going to be more like, can you think about the distance between 2 points? All right, so using this as an example, if A is 5 and B is 2, if I write it as 5 minus 2, I get 3. So that absolute value is 3. If I write it as 2 minus 5, I get -3, but that absolute value or distance is 3. Whether I call it 2 minus 5 or 5 minus 2, you're still telling me it's 3 units between the number 2 and 5. All right, so that's all that this little definition is trying to get at. So, looking at your examples, what you're going to be asked to do. So, first of all, they may want you to just rewrite it without the absolute value bars. Alright, so, if I want, going back to this, if I want this without absolute value bars, it's going to be the right answer. So if I rewrite this without absolute value bars, I would write 5 minus 2. Okay? If I rewrite this without absolute value bars, I would write the opposite of 2 minus 5, because 2 minus 5 is negative 3, and the absolute value gives me the opposite of that. So I put negative, and then parentheses 2 minus 5. Alright, so here, the square root of 150. We don't need to know exactly what that is, other than we know that it's more than 10. If you put the square root of 150 in your calculator, you're going to get a little more than 12. Yeah, you get like 12.247, yuckity. Alright, so this is a little more than 12. So 10 minus 12 is going to be a negative number, right? So this is 12.2-ish. Alright, so that's going to give me a negative. Well, the absolute value bars are going to make it positive. So if this gives me a negative, absolute value is going to do the opposite of that. And that's all that you have to do. If this worked out to be a positive, then you would write down just this part and you wouldn't need that. And it goes back to using this definition that if what's inside is positive, it stays. If what's inside is negative, we do the opposite. Alright, so for our next one, if we're going to evaluate this, so we put a 3 in for the x's, and we put a negative 7 in for the y's. Absolute value of 3 is 3. Absolute value of negative 7 is 7. So this gives me 1, this gives me negative 1. Remember, minus and negative makes a big old plus. So we get 2. Alright, I think that is all that I have. Let me double check. Oh, nope, I forgot. We had one more thing. Sorry. Alright, so property of real numbers. So these are the properties that you've probably learned the first time, like in middle school, honestly, for most of them. So the commutative property is when you have 2 things and the order changes. The associative property is when you have 3 things or more and you change the grouping. So do you see how the order here didn't change, but instead of having B plus C, I changed it to A plus B? So associative is when you regroup things. Distributive is when you make the parentheses go away by saying this goes to both of these. The identity property is what do you do to get that thing back. So for addition, you're going to add 0. For multiplication, you're going to times 1. The inverse property is what do I add to get 0? What do I multiply by to get 1? So inverse property for addition, you're going to add the opposite. For multiplication, you're going to multiply by the reciprocal. Alright, so if we want to match each equation with the property it illustrates, if you look at this, you see how it's 1, 2, 3, 1, 2, 3? All I did is move the parentheses, so I regrouped. So that's the associative. I'm okay if you abbreviate, just be kind with your abbreviations. Alright, for the next one, you have 5 times 1. So if you look at your examples, that looks like this one, right? And I multiply by 1, I get the same thing back. So that's the identity. Alright, here you have parentheses on one side but not on the other. So they did 2 times 3 plus 2 times 4. That's the distributive. Alright, for this last one, we've changed our order. 2 plus 3 became 3 plus 2. So you just switch the order. That's the commutative. Alright, for the next one, again, the numbers are in the same order. We just moved where the parentheses went, so that's associative. You reassociated them. And then F we are adding 0 and getting the same thing back. So that would be considered an identity. All right, so these last 3. Here we're adding the opposites and getting 0. That's the inverse. You're doing the inverse operation, basically. Here you're switching the order that you multiply in, so you're going to use the commutative. And you can just abbreviate, I don't know why. Like whatever you're doing is what order. Anyway, alright, so here you're multiplying by the reciprocal. You're doing the inverse. Alright, so now I really do think that's it. So this is the assignment. Your textbook page is attached so that you can do it from home. If you have questions, please let me know. If you need more examples of something, let me know and I can work a few more out for you and send it to you. It'll probably be 4 o'clock before I can get around to doing that though. All right, let me know if you have questions. Do your work. Send me a pic if you're quarantined.